In this video, let us look into some of the important theorems based on Pythagoras theorem. It is a continuation of previous video. We've also done another theorem based on the Pythagoras theorem. Now what this theorem states is that, now in the given figure here, angle B of the triangle ABC is an acute angle. Acute angle is nothing but an angle which is lesser than 90 degrees. And AD is perpendicular to the line BC. We need to prove that. Now if this is the condition, that if angle B is acute and if AD is perpendicular to BC, we need to prove that AC square equals AB square plus BC square minus 2 times BC multiplied by BD. This is what we have to prove. Now let's see how do we go about proving this statement. Now since triangle ADB is a right angle triangle, which is right angled at D. If you can notice, it is right angled because AD is perpendicular to BC, so this is right angled here. So triangle ADB, which is right angled at D. So if you apply the theorem, that is Pythagoras theorem in the triangle ADB, what we will get is the hypotenuse is AB, right? Because the line opposite to the right angle is the hypotenuse, so we've got AB as the hypotenuse. The theorem is nothing but the hypotenuse square equal to the sum of the square of the other two sides. That is what is the Pythagoras theorem. So what we'll get here is in triangle ADB, we'll get AB square equals AD square plus BD square, right? Now again, triangle ADC is right angle at D. So now since this is the right angle, again this is going to be the hypotenuse for this triangle. Now the most important thing is this hypotenuse is only with respect to the triangle ADB and not with respect to the triangle ABC. And the same thing with this. This hypotenuse is only so because it is with respect to this triangle ADC. So now again triangle ADC is the right angled triangle which is right angled at D. So again by Pythagoras theorem, we have the hypotenuse is AC square, therefore AC square equal to the sum of the square of the other two sides. AC square equals AD square plus DC square. So now what we've got is, now there is a reason that we chose to write this down here, because eventually we're going to substitute this somewhere here. You'll see that how and why. So AC square equals AD square, and DC can be written as BC minus BD, right? So DC square should obviously be written as BC minus BD the whole square, because BC minus BD is DC, so whole squaring that is squaring DC as well. So now AC square equals AD square, and now let's expand this. It is of the form A minus B the whole square. So we've got BC square plus BD square minus 2 times AB, that is nothing but 2 times BC into BD. So now if you can see here, it is AD square plus BD square, right? So let's group AD square and BD square. So AC square equals AD square plus BD square plus BC square minus 2BC multiplied by BD. Now this thing, if you group it, let me continue that here. AC square equals AD square plus BD square is nothing but AB square. So let me write AB square in the place of AD square plus BD square. And let me write the remaining as it is. BC square minus 2BC multiplied by BD. Now this is exactly what we should have proved, and that is what is here. So AC square equals AB square plus BC square minus 2BC multiplied by BD. So this is what we had to prove, and we've proved. Now, before I conclude this video, let me brief this whole thing up for you in a nutshell. Now, what we have to prove is nothing but, now we've got a triangle ABC which has got AD perpendicular to BC, which divides the triangle into two triangles, and both of them are right angled triangles because we've got two right angles here. And because of those right angled triangles, we've got even hypotenuses. Anyways, now because of that, we have to prove that AC square equals AB square plus BC square minus 2 times BC into BD. What do you do to prove this? You first have to take one of the right triangles and apply the Pythagoras theorem and write the equation down, and then take the next triangle and then again apply the Pythagoras theorem and then write the equation down, that is the hypotenuse square equal to the sum of the square of the other two sides. And once you do that, you need to use the previously written Pythagoras theorem equation to substitute in that, and a little manipulation of that is eventually going to lead you to this result. And this is not about proving this result or something, but most importantly applying this result and proving various other kind of problems based on Pythagoras theorem. So that's the most important thing as far as this theorem or result is concerned, more than proving this as such. So it is much advisable for you to get familiar with these results. The series of important theorems based on Pythagoras theorem videos is definitely going to help you solve more problems based on Pythagoras theorem. Those are advanced level problems. I'll see you in the forthcoming videos with more important theorems based on Pythagoras theorem.